Hi guys, my name is Ravi Kumar. So we are discussing nuclear reactor today. Okay, explain the principle and working of nuclear reactor with the help of neat labeled diagram. So before going to this question, what is nuclear reactor and what is the process that is occurring in this nuclear reactor? So nuclear reactor is in the sense we are taking one fuel system, that is uranium fuel material we are taking, and that is bombarded with that is colliding with the neutron, then we are generating the electricity. So this nuclear reactor is the process of nuclear fission reaction. So these all points you may write in your examination. Okay, so without any hesitation you have to write. Okay, so before going to that, write down what is the principle and what are the things that are nuclear fuel, and next moderators, control rods, all I will discuss one by one. Okay, what is the principle first of all? That is, nuclear reactor works on the principle of controlled chain reaction and releases huge amount of energy. So I told you already, that is uranium-235, 92 uranium-235 is the fuel, for example I am taking, and it is bombarded with one neutron, then we are getting two types of nuclei, that is 56 barium 144 and 36 krypton of 89. Then again if you are adding, then you will be getting uranium. But if you are bombarding these two, then you will be getting 3 neutrons here and releases huge amount of energy, that is approximately 200 mega electron volt we are getting. Okay, so this is what the principle of nuclear reactor. And a typical nuclear reactor consists of fuel, moderator, control rods, and next coolant and shieldings. What are those? I will explain here. Okay, so before going to that, first let me check this one. So this is the nuclear reactor process, all this is, and let me discuss one by one. These are the control rods actually. Okay, and these are the dotted lines are moderators. Okay, and in between the moderators, fuel are the fuel rods. In that rods, fuel must be there, that is uranium-235 is the fuel, and this is the coolant momentum rods, pipes we can say, and this is completely water, and this water will absorb the heat from the coolant and releases the steam turbine. Okay, so this is what the process and exactly what is happening I'll tell you. So for example, uranium-235 I am taking in this rods. Okay, for example, one neutron I am taking in this control rods, so that it will collide to this uranium-235 now. So uranium-235 and one neutron will collide. Then this uranium-235 will blast. So that will be barium and krypton you will be getting. So this barium and krypton will be moving here and there like this and will produce more energy, that is approximately 200 mega electron volt. So that will be producing in this, and one uranium-235 will produce this one, and 2, 3, 4, n number of uranium-235 no? That will produce huge amount of energy, and that will be controlled by these moderators and control rods, and this is producing with the coolant, and this will move here and coming back to the same process. Okay, so if it is moving in this direction and this is reaction with water, and the water will get heated, and that will be coming out with the steam turbine, and again the same coolant will come here, and this will slow down the process, and again huge energy will be moving in this, huge heat energy will move in this, and this will move. Okay, so this is completely, that is repeating process. Okay, so one by one I'll discuss. Nuclear fuel is nothing but that is 92 uranium-235 filled in the cylindrical rods that are main core of nuclear. Yes, main core of nuclear reactor. If it is neutron is colliding with uranium, then forming this nuclear reactor, and we are getting electricity. Okay, and moderators, which helps to slow down the fast moving electrons. So fast moving neutrons are there, no? Fast moving neutrons which are slowed down by moderators. The moderators will stop. No, don't go. Come here. They will select that. That are heavy water, salt water, all we are using. In place of moderator, we are using those only. And control rods. Control rods are used for controlling the chain reaction. Boron, cadmium, these are we are using. So that are used to control the chain reaction. So don't do the heavy process. Slow down the process. Like this control rods are doing. And coolant. That heat generated in the reactor removed by the coolant. So in this reactor, heat is generating, no? So this heat removed by the coolant, and here is slowed down and again coming back. Okay, coolant process is very that means crucial part in this. And next, coolant transfers heat in order to generate electricity. This already. Protective shield. Shield prevents radiation coming out from the reactor. So if that means neutrons are moving here and there with the rapid motion, then heavy radiation will produce. That heavy radiation will not coming out. Because these shielding is there, concrete walls these are. So the radiation will not come back. So there is no effect. Okay, we can easily generate electricity with this. That is what the point is. Okay, these are made up of the concrete of 10 meters to 15 meters. That is what somewhat heavy. Okay, so there is no problem at all. So that working we are discussing now. Okay, working is nothing but a single neutron also colliding with uranium atom then produces this electricity, and this all starting nuclear fission process. So nuclear fission process is nothing but that one neutron, that means one neutron is colliding with the heavy nucleus, then forming two smaller nuclei. That is known as nuclear fission process. Fission is nothing but heavy nuclei forming two smaller nuclei. So fusion is nothing but two smaller nuclei forming heavy nuclei. Fuse means fuse. Fission means separate. That's what you should keep in mind. So no external source is required to start. Only one neutron is enough. Okay. Fuel filled in aluminium cylindrical rods and arranged at equal distances. These are the aluminium cylindrical rods, and that are separated by the same distance, equal distances. And next, fast neutrons pass through the moderator, then their kinetic energy will be loosened. Okay. Fast neutrons are moving here and there. So this moderator will stop. No, don't go. Here you should stop. So that loses the kinetic energy. Because of the moderator, they are losing, the neutrons losing kinetic energy. And next, by the movement of control rods inside and outside. So these control rods are there, no? They are moving inside and outside, so that the reaction rate can be controlled. The reaction, that means there is no more reaction. If it is like this only, then uranium fuel is there, no? This will continuously bombard it. If it is moving upwards, then there is no bombarding. If it is coming, then bombarding is there. So that's why this will move upwards and downwards to slow down or control the chain reaction. Okay. The heat generated is used to heat the coolant and produce the steam at high pressure. It produces high pressure, so that we can easily generate the electricity here. Okay. So that are the uses, and the nuclear reactor is used to generate electric power. This already we know, and these are used to produce radioisotopes. Okay. So this is the end of our question. If you are writing like this, then you will be getting out of marks for this question. Hope you understood the video. Have a nice day. I'll meet you in the next lecture.